All right, guys, we're going to talk about another type of area formula today, although this one should feel like a little bit of a review as well. So like the parallelogram ones, I feel like we talked about, and triangle we had already talked about. These ones were slightly new, but today we're going to do area of a circle, which we did do before, and a sector, which we haven't talked about a sector before, but I think you'll think it's pretty easy, and we're doing that on 110. Alrighty. So if we turn to that page there, let's start with the easy one first. So area of a circle, like I said, pretty sure we did this before. Area of a circle, I'm just doing pi r squared, where r stands for the radius. And I can always remember that this one is the one for area and not the other one because of our units squared. So because area is always in units squared and this one is being squared, this is the formula that I want with pi, not the other one. That circumference. So if the radius here is 5, if I want the exact area, I'm going to put pi times 5 squared. I would square the 5 for 25 and put pi at the end. It's a little bit more appropriate. And we'd say units squared. Now, if I want the approximate area, which sometimes I do want approximate area, I need to then go and multiply by pi. So I think our iPhones and our Androids have this. If you go to your calculator and you do 25 times the pi button, don't use 3.14. That's not enough. Pi is really long. It's endless. You want to multiply by all of it. So times pi, and we get a better answer that is less approximated. And so the approximate area is 78.54 if we decide to round to their units squared. So let's open that up and try a whole bunch of those. So if this first one here says find the area, I can see that they're showing me the radius is 6. So we'll do area equals pi r squared, where r is 6. And so the exact area is 36 pi units squared. The approximate area is going to be 36 times pi, so 113.1. We'll go there. Units squared. Okay. On that next one, find the area. That one I don't think they're showing me the radius. They're showing you the full diameter. So the diameter is double the radius, which means your radius is half the diameter. So half of this is going to be 7.5. Super yuck. Let's do 15 over 2. I can't even do it. I can't. 15 over 2. So pi r squared, where the radius is 15 over 2, and we're going to square it, which the reason I chose to actually do it is so we could talk about how you square a fraction. It's actually not that bad. You just square both things. So like 15 squared is 225, and 2 squared is 4. So that is our exact area, units squared. If I want the approximate, I'm going to type in 225 divided by 4 to get like the radius squared, and then multiply that by pi. So the approximate area is 176.71 units squared. I kind of did go to 2 here, but it still needed to round it up. So I guess I could put the 0 to like be consistent with where I'm rounding to. I always just hate to put a like useless 0. Like that is a unnecessary 0. But anyways. All right, looking at these last two. These last two are kind of backwards problems. It says find the radius. So here they're showing you that the area is 16 units squared. And so I know the formula for area of a circle is pi r squared. Then since they've told me that the area is 16, I'm going to put that in for A. And then we'll have pi r squared. And then we just want to solve. So like to solve for r, I have to get rid of pi because that's being multiplied, and then get rid of the exponent because exponent is like later in the list. So I divide both sides by pi. And so I can do that like straight up on my calculator. 16 divided by pi, which is, and can only get approximate radius here, which is super annoying because like if I'm going to divide by pi, the moment I write this decimal down, it's going to be rounded. And then when I have to square root it again, because like getting rid of the squared, I'm going to have to square root it. I'm going to have to round that too. So it really super sucks. You're getting a really approximated radius here, but kind of all you can do. So get 5.09. Now the thing is, I don't want to erase this and then retype in 5.09 because I chopped a whole bunch of that information off. So try to leave this number in your calculator, and now we're going to square root it. So I just hit the square root button, which we have over here, and it does it right for you. So 2.26 is the approximate radius for that one. It's nicer if they give you the area in terms of pi, so like you don't lose information, but of course they didn't. So here we want to find the diameter, which is low-key like finding the radius and then just doubling it. Again, when they've given me the area, so area equals pi r squared. We'll put 31.4 in for area. And then we'll divide that pi away, which just will work a little bit nicer. 31.4 divided by pi, only because like that's kind of pi. So like we're basically at 10 for the radius squared, and then we'll square root both sides. But again, like I'm not going to square root 9.99. I'm going to square root all this. Like I like to leave it up on my calculator because that means I haven't rounded anything. So now I'll square root it. So 3.16 is approximately the radius, but I want the diameter, which is double this. So I'm just going to times both things by 2 now, or just take this whole thing and double it times by 2. And so now I can see that the diameter is approximately 6.32. Okay, let's talk about the slightly new formula that we have here. So a sector is really just a part of a circle. So like if I think about the most circular food that I know, pizza, this is me eating the whole pizza, which is not advised. Not advised. Don't eat the whole pizza. I mean, you guys are grown boys and girls. You can eat the whole pizza, but I shouldn't eat the whole pizza. If you're going to be more responsible like me and not eat the whole pizza and just eat a couple slices or like a really big slice, then you're eating a sector of the pizza. So let's say, for instance, I wanted to just find how much pizza right here I ate. So this one, like we're finding the full area of the pizza, all that stuff. But if this one I'm only finding that much, because that's the only area of the pizza I want to eat, then it's kind of like I'm doing a portion of the circle. So really, when I'm finding the area of a sector, I have area of a circle right here. And then I'm really just almost taking like a percentage of it, except in a circle, the percentage isn't out of 100, it's out of 360 because there are 360 degrees in a circle. So I'm just telling like whoever wants to know, how much of that 360 degree circle did you want me to eat? And so in this case, I wanted to eat 100 degrees of the 360 degree pizza. So 100 out of 360 times pi r squared, which they're telling me r is 5 again. So there's kind of a lot of different ways you can simplify here. I'm going to square that for 25. So I'll have 100 over 360 and then times our 25 pi. Now, a couple things that I noticed really quickly is like I can divide a 0 out of each of these, like a 10 out of each of those. Because the thing is, like the 25 over 1, like really these two fractions I can simplify simultaneously, sort of. Like I can cross cancel, or I can like cancel straight up and down. Like I canceled right here the 10 straight up and down. But if 36 and 25 like had something in common that I could cross divide, I might do that, but they don't. So, but like I can simplify more this way. I can't simplify that way. I know the 10 and 25 have a 5 in common, but you have to go top to bottom always, not side to side. So 10 and 36 at least have a 2 in common. So now this is 5, and that's 18. And I feel like that's the best I can get in terms of simplifying here. So now across the top, I really have 5 times 25, or 5 quarters, which is $1.25, over 18, and then pi at the end, units squared for our exact area. But if I want the approximate one, I'm having to go to my calculator now and turn it sideways. And we're going to be doing, oh my gosh, look how dirty that is. Yuck. 125 divided by the 18, and then multiplying that by pi. Because again, sometimes we want approximate area. So 21.82 units squared. And again, that's not the whole circle. If you remember, the whole circle was 78.54 units. This is only 21 units. So you didn't eat the whole pizza. Good for you. Okay, let's try a bunch more of those. Should have gone with a donut. I'll always eat a whole donut though, so I'm not ever eating half a donut or 100 degrees of a donut. We're eating that full 360 of the donut. Alrighty, so if this sector I want to find the area of is 120 degrees, we're going to do area equals 120 over 360, because that's how much of the circle I want, times the area of it, pi r squared, which they're showing me that the radius is 4. So again, I always like to divide the zeros right out if you have them. And so really what I have here is 12 over 36, which I know I can simplify more, but let me do the radius because maybe that'll help me simplify in a more interesting way. Because like I could do the 36 and 16, and 4 will go into both those. Let's do it. So 4 goes into 16 4 times, and into 36 9 times. And now I can't really cross cancel anymore. But I can cancel up and down right here with the 9 and 12 because 3 goes into both of those. So 3 times here and 4 times there. And remember, I can't cancel these because they're both on top. So what I have left on top is a 4 and a 4 for 16. What I have left on bottom is a 3. And so that is the exact area of this sector. And then if I want the approximate, which sometimes we want the approximate. Oops, gosh, darn it. I would do 16 divided by 3, and then times by pi. So 16.76 units squared. Which if you compare that to the full area, which would just be 16 pi, it should be less. So, and it is, which is good. Alrighty, trying this one here. If I want to find the area of this mostly eaten pizza, we're going to do 200 degrees out of 360 because that's how much they want. That's like the shaded region, times pi r squared, where they're showing me that the radius is 6. So 36, I'm sorry, I did it fast. Is that okay? Squaring my radius is so easy. Oh, and then I noticed the 36 and the 36 right here. I'm not even going to get rid of the 0. Like 36 goes into 360 10 times. And then I'm just doing 10 into 200 because this like fully divided out over here, which is 20. So I just get 20 pi straight up, which that's freaking nice. And then if I want the approximate area, no crazy fraction stuff left on that one, 20 times pi is 62.83 units squared, which to just compare that to the full on area, which would have been 36 pi, I get 113. So, which is almost like half. Is it? Well, yeah, kind of. It's almost like half. And like half of 360 is 180. Oh, and 200 is not much bigger, so that feels good and makes sense. Okay. Which, speaking of, this is exactly half. Like 180 degrees is exactly half. Which you could do that right off the top if you wanted, but let's just be straightforward with it. So we're going to do the amount of degrees I want to eat of the pizza out of 360, the total, times our pi r squared, which is 10 squared, so 100. Now again, if you're really good at noticing like what half of 360 is, like I just simplify this right now to half. And then I could just take half of 100 for 50. So 50 pi is the exact area unit squared. If I want the full, or the approximate, we're going to do 50 times pi, which is 157.08 units squared, which again, if you compare that to full on area, which is 100 pi, it should be like exactly double that. And like 300 and half is 150, and then half of 14 is 7. So hopefully that makes sense and feels good. Sorry, this is blurry for some reason. It's because I keep moving my phone in and out of frame. All right, last area of sector. I love area of sector. Like you think it's going to be hard, but it's really just like a portion of it, a percentage of it out of 360. So this one, again, because I'm like used to doing multiples of 360, like I know that 90 is like a quarter. Like if 180 was half and 90 is half of that, a half of a half is a quarter. So you could kind of just put 1/4 right here right now, but that's okay. We can still put the 90 and go slow, times pi r squared, which is 8 squared, which is 64. And I kind of like that I can show you, you know, the zeros still divide out, and then 9 into 36 is 4, but it's got to go on the bottom because the 36 was bigger. So that's why 1/4. And then a fourth of 64 is actually pretty nice as well. I think that's, what is that, 16? Yeah. So I get a really nice area again, 16 pi units squared. No crazy fraction stuff. Which can have, like, the crazy fraction thing is honestly more, like, more often going to happen than this super nice working out sort of sector area stuff, unfortunately. So the approximate area here is 50.27 units squared, which again, if I want to compare that to, so if I quadruple this, because I had a fourth of the area, so if I times that by 4, I get 200-ish. If I compare that to the true area of the full circle, 64 times pi, 200-ish. Okay, sorry, I'm nerding out. That's it for today, guys. I'll see you on the next one.